the time here.
Okay, yeah, okay.
Yeah?
Yeah. I should have, I've got handwritten notes, I should have put them there.
Yeah. Yeah.
Pardon?
Yeah.
No, I on a piece of paper. I should have put them in there. I just
Yeah.
I wasn't sure how it would be set up. That's all right. So the blue's readable.
Yeah.
You think it'd be okay?
I think so.
Ja, zo. We weten de andere wat.
And that's
Yeah. Right. Yeah, you're just gonna plug in. Okay.
thank you.
Thank you.
Zo, Filina.
Yeah.
Yeah, I better do that.
Thanks, Olivia. Portugal?
Portugal, no. Let me see. Portugal.
Mm-hmm.
Presentation. Number 5. I prefer better PPT or better PDF? Better PPT.
Yeah.
Okay. Would you like to
Yeah,
verify?
yeah. We're gonna check.
No, not this. No.
Oh,
You
sorry.
open the other.
Yes. Still too early now.
It's all right. So,
Hey,
as
Mike.
a Superman. Yeah, morning, Mike. Morning. It's okay? Bom dia. Okay. Thank you, Tilina. You
Do you
checked?
wanna check?
Yeah, it's all right. It's
Okay.
all right.
Hey, thanks.
I think the last one.
Okay.
Thank you, Tilina.
Thank you.
Thank you very much.
Then it must have been just the right amount.
I hope.
It's a.
Let's look down at, well, let's see. You'll say Simmons AWB, and I didn't bother to put
Okay,
this.
that one.
Is that today's date?
Yep.
Yeah, of course, because I was finishing it this morning. How did you sleep?
Pretty late, actually. Well, I took a nap and then woke up, so it's.
Oh, yeah, it can be good, it can be bad.
Yeah.
So, I had a terrible night, I don't know why. Very rare for me. Would be it. What program is it that does that? Presents it so nicely with the preview and everything. Is this a Mac or a PC?
No, it's a PC.
I need whatever it is that does.
Yeah, it's a really small program actually.
That does what?
Good morning.
Well, it shows the
morning.
preview and shows your notes and everything, so you can see it.
That's a normal PowerPoint. As long as you
Does it do that?
yeah, as long as you don't mirror the screens, you extend desktop, so you have like two desktops. And then one is presenter view, and you have that open.
MLS
Never
sharing.
tried it.
Yeah.
Morning.
So there's a kind of different
You
feature
have the
that
presentations
can't mirror
already
your,
there? All
Your,
three.
your,
Okay.
your screens.
Yeah,
pretty much.
yeah. I never, because I was using an older version for a long time, and then I just recently upgraded. So
Are they all done?
So we have everyone.
So I'm always sharing immediately here. Okay.
Yeah, you're sharing this.
All right. Okay. Great.
He's not coming.
Great. Oh.
No, don't say anything. My first reaction was to send a very nasty email. Then I said, okay, Jose, breathe, go. At the end of the day, you send it. He's not coming anyway.
He has a talk,
I know.
and then
And Ido also is not coming.
cancel.
So we will have a bigger coffee break in Portugal.
We can do something actually.
Yeah?
Sorry.
No, you shouldn't.
Yeah, it's very
But I talk
Why are you
with-
doing this?
I talk with because I'm using my laptop.
Ah,
But you can email your presentation.
Afterwards,
Yeah.
I'm gonna record it.
Okay then.
safe? That's all.
It's safe. It's safe. Oopsie. Just.
That's
You think he will,
no, it's fine.
is okay
You
here,
can
Pedro?
actually keep. Yeah.
Actually, why don't we take?
Yeah.
Exactly, we put on top of the table.
Yeah. But we can just.
You know Murphy's law? And I don't want you to fall out of the. So who is sharing the session from? Right? Okay. Everything okay, Pedro?
I hope so.
Good morning, everyone. Welcome to the second day of the Astronomy Education Alliance meeting. And I was not supposed to share the meeting today, but fortunately enough, the person who is going to share didn't appear yet. So it is my privilege to present Pedro Russo, whom I know since 2009, no, before that, much before that. 2005 or 6. And we started talking, and he's... Now you're calling me old. That's not nice, Pedro. So he was very guilty for the Galileo teacher training program, and he helped us develop all the structure that is out there today. And we now are together in a new adventure for next year. So he's doing a wonderful job, and I really am proud to present Pedro Russo, who is going to talk about a 5-year vision. I'm looking forward to hear that. Welcome, Pedro.
Thank you, Rosa. And also thank you so much for coming so early. And it's also a privilege for me to be here. I think it's one of the first times that we managed to bring together different communities and discuss astronomy education. I mean, we had the Global Hands-on Universe as a meeting for many, many years. We organized some universe awareness workshops. There's the ASP meeting, a big meeting in the US. There's several efforts of astronomy education. And I think this is for the first time that different people from the community is coming together and discussing a bit of astronomy education. So when Rosa invited me to give a talk, I thought that I could present some of my thoughts, and this is a very personal talk in a way, about what should be astronomy education community as a whole, all of us together. So this is definitely a personal vision and definitely a work in progress and a draft, if you want to see it. It's really, the idea is to start a discussion, and this is the right place, and I think we have the right number. There's around 50 or 60 people, so we can really discuss and engage on an interesting discussion on what should be astronomy education and where should we be at in 5 years. So this is really a starting point of the future of our field. And this started, and why 5 years? There's several reasons. I think the main one is because the IAU, and the IAU is the international body of the professional astronomers all around the world, endorsed in 2009 a strategic plan that we call the IAU Strategic Plan 2010-2020, and pretty much we'll finish this plan in 5 years, so we can work together to try to make this plan happen. And some of our colleagues, Isabel from the Planetarium yesterday, also mentioned that for us Europeans, there's also another strategic plan that's called Europe 2020. It's trying also to make Europe a knowledge society. And education, science and technology, research and innovation plays a big role. So all of this coming together, I thought that having a 5-year plan could be a good starting point for the discussion. And it's quite a short-term goal as well, that we can all together work. So once again, this is a draft, this is personal, and I think this is just to start a discussion. So I'll try to keep my talk short so we can engage in some discussions, and then afterwards we can also discuss. So I think the top level goal is really, let's try to find a way to engage all young people with astronomy. And when I say all young people, it's pretty much before the end of secondary school. Every single child and student should have a contact with astronomy. Somehow, looking through a telescope, getting acquainted with some of the concepts and knowledge that we have in astronomy, and trying really to, at least to have this first contact with astronomy. And if it's possible, make them look through a telescope. I think that would be a wonderful thing to achieve if we could, all of us, work together. At least have some contact with astronomy. That should be our goal. Everyone around the world before they finish high school. And for that, I think the best way to achieve it is really to make astronomy part of the national curriculum. It's quite of a dream. I think there's a very few countries that I know that have astronomy as part of the curriculum. Most of the curriculum touch different fields of astronomy. But if we could work together to try to make astronomy part of the curriculum, that also could be an interesting thing. And we all come from different countries, so we can try to work with our national authorities and make this happen. But this is not enough. I think we need to really make astronomy accessible through several informal learning spaces. And we do have science centers, we do have planetariums, but we need to go beyond that. There are several studies like we saw yesterday, that informal centers are really a wonderful place for people to engage with science. But we also know that most of the people coming to the science centers, they're already interested in science. So we need to go beyond that. We need to work with the national parks. We need to work with arts communities. We need to work with the cultural communities and trying to bring astronomy to places where where usually people don't expect to see astronomy. And so informal learning spaces are not only science centers, are more than that. And we need to find ways to introduce astronomy in these informal learning centers. We talk a lot about science education. There are several studies. The Royal Society in the UK had a wonderful study released a couple of months ago that I will recommend for all of you to read about science education. And they say that we should place science at the heart of education. And I'll go beyond that. I think we should place astronomy at the heart of science education, because astronomy really plays an important role in many areas of knowledge, science, technology, and culture. I'm sure that most of you have seen this slide where there's a nice overview, and this was presented in the strategic plan from the IAU, where it's a nice overview about the connections of astronomy with different areas of science, technology, but also culture and society. I think all of us here are aware of that. We are about how astronomy contributes to developing technologies in terms of space research, hardware, software, space technologies, but of course all the links with the other sciences, from physics, chemistry, mathematics, and of course a very hot topic, astrobiology and biology, but of course the cultural aspects of it, the history, when we look back in time, like we do in astronomy, anthropology. Most of the ancient civilizations, if not all of them, had somehow a connection with the cosmology and their own understanding of the cosmos. It's quite an ancient science. Inspiration, astronomy and space can really inspire young children to come to science and technology and be engaged in science and technology. And of course, the perspective, one of the unique selling points of our field, that when we look to Earth from space, it's quite a changing experience that many astronauts also felt. And now, thanks to space technology, we can also feel it. But I think something that we need to work with as a community is to increase our quality standards and also work in common frameworks. I think we are quite a diverse community. We have different techniques, we have different methodologies, we have different ways of working, but I think we need to find a way to know where is our starting point and set that bar quite high and build on that. I think I see a lot of diversity of activities, but sometimes I feel that also it's difficult for people to find a starting point where you can improve what is already out there. So one of the things that we realized working with my team is that it was very hard for us to develop activities for specific age groups because we didn't know what children and students can learn at that age. There's very few research on that. We started working on that, and Eric Herrens will give a talk a bit about this today, and I think it's this afternoon or this morning, and it's about astronomy literacy benchmarks. In the US and many other countries, they have these science benchmarks, and many other fields like climate sciences and earth science, they already established what they call their literacy goals, and I think this is missing in our field. We don't know at what age people are able to learn, what an 11-year-old can learn about the universe, what the science education research tells us about it. So we started embarking on this study, trying to understand what we can do in astronomy literacy benchmarks and try to set these benchmarks as a community. And again, we have to do this all together as a community. Another important thing is that we need to make our educational resources open educational resources. I see a lot of educational resources produced, but most of them are quite hard for people to translate, localize, adapt to their own languages. They are closed systems, they are not open, people don't know what kind of license they have, so we need to make sure that all our educational resources that we produce, and especially the ones that are paid by public money, are open educational resources. So just a reminder for the ones that don't know what the open education resource is, are freely available with open licenses, documents and media that we can use for teach, learn, and assess, like to study the impact. So when we produce an activity guide, when you produce a new video, make sure that you make it freely available online with an open license, like Creative Commons license, so people from all around the world can use that and build on that and improve on that. I think that's an important aspect when we develop new resources. Another thing is that, as you know, we have been working on, and Tilina will give a talk today also about it, is the astronomy education platform for education resources, AstroEdu, that we are trying to improve the quality of the resources and reach highest standards of quality. And Tilina will develop a bit more this concept today during a talk, and this afternoon we're going to have a workshop about AstroEdu that we are all invited as well. Like Pamela said yesterday, we also need to work with a common development framework. I know that this sounds quite a big word, but I think she put it very nicely yesterday with the Bloom's taxonomy. Bloom's developed this new taxonomy, how to develop activities, ideas, lessons plans based on the different concepts from science education. And I think it's worth spending some time looking into this Bloom's taxonomy. Recently, the National Academies in the US also released different levels of learning science, and a very nice document about learning science in informal settings. And pretty much they set different levels of how kids and how students and how people develop and learn science. And these are pretty much from the first level all the way up until people actually identify themselves with the scientific enterprise and they participate in an active way in the scientific discovery, like through citizen science, for example. And of course, developing an interest in science is most of the science centers are doing. They open their doors to children, to the public, so people can start developing an interest in science. And then we can try to develop on that. And our activities should also follow this path. So we can start developing an interest until all the way up, where people can feel themselves part of the scientific process. And that's a quite nice way to design and to develop our activities. Another thing that is also very important, and we need to embrace new technologies and new methodologies. We as an astronomy field, and of course also in planetary sciences, we are developing some of the most advanced technologies that in the world. We put amazing spacecrafts in space. We develop 30 meters telescopes. We really are pushing the technology limits all the time. And we need also, as a community, to embrace these new technologies and use them. And there's so many things happening in learning. And also, Carl yesterday said that the classroom environment is changing so fast as well. The new technologies are coming. The internet changed the way that we learn. And as we know, astronomy learning and science learning and learning happens everywhere, anytime. People can just get to their devices and start learning about something. So we also need to embrace this. So make sure that when we develop something new like resources, make it available that can be accessible anytime, anywhere, in any device, from mobiles, phones, etc. And there are several examples of these new technologies, MOOCs being the maybe most popular one, but there's other things like crowd learning, people sharing knowledge online and having these virtual classrooms where they get together and learn something. Learning from gaming. Serious gaming is a big thing in many, many fields. People play and learn something. The maker culture that I think is very close to the amateur astronomy community as well. I mean, the amateur astronomy community has been a maker culture for many, many decades, building their own telescopes, making things. It's a quite trendy topic. There's makers fairs everywhere, and there's a lot of people trying to do their own things. And in astronomy, I've been doing this for many, many years. And of course, citizen science. It's, I think some of the most successful cases of citizen science are coming from astronomy. And we have to find a way to use that for people also to learn more about astronomy. And astronomy education is evidence-based education. I think this is an important one, and sometimes we forget. I think sometimes we just go with our gut feeling. We think that this is going to work, and we forget to go back to literature and to see if this worked in the past or if it didn't work in the past. I think sometimes when we develop new things, new teacher trainings, we forget to go back to literature to see if this worked, if there was something that tried to do something like this or not. And of course, part of this is inquiry-based learning is core to our work. I think it's quite well known that it works. It works in many different settings, many different environments, and I think it's the best way that we can use at the moment to teach astronomy. And astronomy education is cultural aware and inclusive. I think many of the people in this room are aware of that we as astronomers, we can use culture as an engaging hook for astronomy, but we also need to make our resources in a way that people from other cultures can also use them. And I know this is a typical case that sometimes we forget that people live in the southern hemisphere, that they see the moon slightly different, that some of the constellations are not present there, and I know that some of our colleagues in the southern hemisphere, most of the times they cannot use our resources from the northern hemisphere because we forgot about this particular point, and then it's not available it's not possible for them to use the resources. And also, I know that there's a lot of people that have been developing activities, especially for the blind people, and this is also an important aspect that I think we are working together, but we maybe need to improve a bit more. And teacher training is a collaborative effort. I think it's a collaborative effort between astronomers, teachers, educators, but also the educational authorities on your region or your country, and the academic institutions that are providing training to the teachers. I'm based in the Netherlands at University of Leiden, and we have been quite successful engaging with the teacher training centers, so the schools for future teachers, in teacher training. We decided to have that approach, to work with the teachers when they are still in training, so they can afterwards go to the schools and actually improve the use of astronomy and science in the classroom. And I think this is a quite good approach in teacher training. Not only work with teachers already in service, but work with teachers pre-service. I think it's a good example, a good best practice of our field. So I think by 2020, we, astronomy education communities or astronomy education community, we have facilitated the increase of astronomy education research. I think this is something that Paulo is going to talk about. And at the moment, I did a bit of research, and we have around 500 papers published in 2013 on topics related to astronomy education. It's quite easy to do, just Google Scholar and try to see how many publications are in this particular field. But I think we need to improve that. Some of the activities I've seen here, we don't report back our successes, our failures. We don't have a reporting culture in our community. Not yet. I think we have to improve that. We need to make sure that our lessons are shared with the rest of the community so we can improve. So I think we need to have better training on reporting, evaluating, impact assessment. I think we need to provide the tools and methodologies so we as a community can do it. And the IAU Commission 46 on astronomy is putting together a working group to look into this and how we can improve that. I think we facilitated the training by 2020, we facilitated the training of hundreds of thousands of teachers. If not, why not 1 million of teachers by the end of 2020? And I think that these numbers are not completely correct. It's difficult to measure how many teachers we are training at the moment, but roughly from GTTP, Universal Awareness, other initiatives, I roughly calculate that as a community we are training around 50,000 teachers per year in average. But I think we can increase this number if we work together and also trying to find ways to reach more teachers because they are a wonderful multiplier. And for that I think we need to work also on the accreditation of these teacher training programs. I know that some countries are working independently, but it could be a good idea to have an IAU level accreditation for the teacher training initiatives. It's something that we have been talking since 2009, International of Astronomy, but it's quite a complex process, but maybe you can restart the discussion. I think will be quite interesting. So, and we facilitate inclusion of astronomy in the curriculum of dozens of countries at least. I don't know how many countries have astronomy in the curriculum. I know some of regions and some countries do have astronomy in the curriculum. But we also know that it's quite difficult to include the astronomy in the curriculum of countries because we also don't have a starting point. Imagine that a country like, I don't even know if, for example, Rwanda wants to have astronomy in the curriculum. What can we provide them? I think the astronomy literacy document could be a good base for them to work on. It's if we get a request from an authority. And maybe we should identify potential entry points and work at the national level with national authorities. So we also facilitate the production and distribution of hundreds of educational resources around the world. And I think dozens, if not maybe even hundreds of resources are produced every year. And we need to make them more open, and we need to increase their educational quality. So I think AstroEdu and other platforms can help that. So in this way, we hope to reach millions of children and teenagers by the end of 2020. I think that's actually our goal. We need to put maybe a number to this, but I think we can easily reach millions of children and students around the world by the end of 2020, and that's our ultimate goal. But before I finish, I'd like to say that for this to happen, it's not only our work that needs that is not only us, that we need to improve the way that we work. I think we need to find ways to make education a structural part of astronomy as a field. At the moment, we know that astronomy is funded by side projects, side grants, and is not a structural funding coming from the agencies. We also know that organizations like ESO, ESA, NASA, they spend between 0.5, 1.5, some studies indicate 2% for NASA, on education and public outreach initiatives. But we also know that public outreach, media relations, is taking big part of this budget, if not 90% of this budget. Education, I don't even know, it's very, very small part of the budget of these agencies. So we need to increase that. I give a number, at least it would be great to have at least 2% of the budget of these organizations just for education, not even media relations or public outreach, just for education. And we need to find ways to do it. But for that, we need to also to show them that we are successful and we can create an impact. And I think we are not at that level. I think it's very hard for us to tell our colleagues what real impact we are having. So we need to work on that. So we have to work with our organizations, and most of us have organizations behind. We work at universities, agencies, institutions, so we have to work at least with our organizations. And we also have to lobby our colleagues, astronomy researchers, because they have a saying most of the times on the funding that they can have. So we have to work with our colleagues and show them that these can have a long-term impact. So in a way, and to finish, I think astronomy education community works together. We all work together, and we also learn together as a community. So this is my last slide before the end. Thank you. Sure.
I really enjoyed this talk. Thank you very much. I missed where the astronomy or was it science literacy? Where did that come from?
So astronomy literacy is something that in many countries exists. In the US, it's a quite big topic where they set a set of knowledge, facts, concepts, or ideas that children or students should have at certain ages or certain development phases of their lives.
All right, that's what I thought you said, and I remember seeing those in the US, but I wasn't sure if that's where you got them. All right.
Exactly. That was our base, how we should have some specific ones for astronomy. Because the ones that we have been looking at, they are a bit outdated, or they don't have all the things that we believe they should be part of these astronomy literacy goals.
Okay, I have one more comment. While I'm sitting back just thinking about all of this and taking it in, I think sometimes in smaller countries, these are easier to implement than in the U.S. because it's so big. So doing it state by state in the U.S. is probably the best focus. At any rate, thank you very much.
Thank you so much.
This is great, Pedro. Hey, just had two remarks. One, and maybe we can reply to both at the end. One was, I really like the idea of an IAU set of astronomy learning goals for each age group. Now, there's been a lot of, in the United States, PISA, Europe. I think that would not be hard to construct, but if we could keep it very simple, like maybe three per age level or something, then that, I think they'll be much more likely to be adopted. I mean, the United States in the new science standards has, another 10,000-page document that's very useless. And keeping, like three levels or, 3 or 4 bullets for 3 age groups, I think would be fantastic. And also, another thing, if it was very simple, it'd be very easy to get assessment items to test against. And I'm sure our kids are learning with HOU-type activities, 5 times more than Sage on the Stage lecture things. So if we can clarify what the learning goals are, then, for each age level, then the curriculum we can teach it. We can let the old school teach their way. We could teach it HOU way, GTTP way, and I'm sure we do 10 times better than the old school. And then I think the money will flow, the ministries of education will cave in, et cetera, et cetera. And I think that evidence collecting is going to be easier and easier for us all.
Exactly. Thank you, Carl. And we have been looking at different literacy of other sciences, and the atmospheric, I think it was atmospheric science colleagues, they did what they call big idea, and they only have 6 of them, and then they break down in different ones. And I really like that approach, because then it's really, really well focused. And like you're saying, then assessment also makes it easier. And everything is in a way connected. Developing new material, providing teacher training. If we can work on that as a common framework, then I think we can improve a lot what the things that we are doing now.
So we have to stop the questions now, but I want to finish by saying just one thing. My mother taught me that we have to be careful what we wish for, because wishes do tend to come true. So I really hope that you manage to do all that you said, because that will make life much more easier, much, much, much more easier.
Thank you, Rosa. I have a couple of announcements about the not related with the talk, but related with some of the side events that we are organizing, and a lot of people have been asking questions. The first one is tonight we are having a public talk about Rosetta. It's going to be in English, even if the poster is in Portuguese. So Matt Taylor is a Rosetta scientist, the main scientist from ESA, from the mission, is giving a talk, and I know that he's a very good speaker, so I'm really looking forward to this talk. And he's in the science center, in the main science center in Lisbon. So it's quite far from here where we are in Estoril. But we have some of the possible ways to get there. So I think the best way is really to get to Cais do Sodré. That is the last stop from the Cascais train. And from there, if you're like a small group of 4 people, you can take a taxi. I think it's going to be around 15 euros per person to the science center. Or you can take the metro line. You have to take 2 lines, and last stop Orient, and then from there you can navigate or through yourself to the Pavilhão do Conhecimento. Some of the post-conference activities that we are also organizing related with the International Year of Light. The first one is, by chance, this weekend is the Light Festival in Cascais, and starts Friday evening. So Friday you can already explore and enjoy some of the art installations that they are having in Cascais. So it's a couple of stops from here, and starts Friday evening, and I think it's going to be a very nice event. The website is very nice with all the information, English website, so I'll definitely recommend you to go there Friday and explore a bit more Cascais. As you also know, we are organizing some side events in a Museu of Light that's called Museu da Luz, a bit far from Lisbon, Cascais, but quite nice location in the Alentejo region of Portugal. And we're going to have a lecture from Babak Trafeshi. He's going to be giving a talk about the world at night, and shows beautiful pictures. And if you guys are into astrophotography, it's a great opportunity to get to know some of the top levels, one of the top level astrophotographers that we have in our community. And then we're going to have the day after a very short workshop with some of the people here, and we're going to discuss how to increase the impact of global project at local level. I think sometimes it's disconnected to what we do at the global level, and we need to find a way how we can increase the impact at the local level. That's going to try to address this question in this workshop. So you can register here on this website. Some of the people already did. And there's also suggestions for accommodation around the area. And there's different levels. And also, if you are a group, we are trying to find lifts for everyone. But maybe if you have a group of 4 and if you feel brave enough to drive, and it's quite okay to drive here, you can just rent a car. It's not very expensive for 4 people. And it's a highway all the way there, quite easy to get there, easy drive. So it's also a possibility to rent a car and join us in these 2 days event. Thank you, Rosa.
I just want to add that for today, for the Knowledge Pavilion, if you organize yourselves, or you can talk to Lina back there, and we will have someone, if you want to go by train and metro, some of our people are going with you so that you know your way to the Knowledge Pavilion. And also, as I said yesterday, the Knowledge Pavilion is open to everyone that would like to visit before the conference. Okay? Okay, so we move now to our second talk. We have now Paulo Bretones, who is going to talk to us about astronomy, education research, results and perspectives. I'm really looking forward to hear Paulo's talk. I know Paulo is also a member of Commission 46 of the International Astronomical Union. He's Brazilian like me, so I'm really looking forward to see what developments since the last time I heard you. It was in 2000, no, it was in China. In China. So I think we all have a lot to learn. Well, while they start the computer, let me finish the announcements wave. We don't have Michel Fay today. He's not coming, so all of you don't have to split yourselves in 2. You can attend the Astro Edu workshop, and I suggest that I strongly suggest that you participate. It will take place in this room, okay? Last but not least, tomorrow we have the conference dinner. Buses are going to leave at 5:45. We cannot wait for everyone, so please be there on time. We're going to go in 4 buses, a lot of people going. If you didn't pay yet, please do so. They tend to ask us to pay for dinners. Damn it. Okay, Paulo, it's your time. I will let you know when you have 5 minutes.
Okay. Good morning. I'm very glad to be here with you and to meeting many colleagues, many friends. I would like to talk about this issue, astronomy education research, results, and perspectives. So, just for beginning, it's very common to hear from professional astronomers that research against teaching. It's common on the language of the people of research on specific content of astronomy or astrophysics, that research is one thing and teaching is another thing. And that is that astronomy versus education. Another thing is that content versus method, thinking versus doing, or studies versus services, doing services, or discovery versus denouncing. So we are talking about research in education or on education. So to start, it's important to say that astronomy education research may have several applications and motivations for the people. The first is the personal interest to obtain knowledge. Another one is to enhance their practice. Another is the career advancement and advancement of the field of the knowledge. So, astronomy education research has many output. We have PhD and master theses, we have proceedings of meetings and published papers. How to investigate this output? This is our goal, is to is about. The papers can be classified by country, institution, grade level, topic or content, focus of studying in education, type of academic research, and theoretical framework. So what are the focus on the study of education? If we are talking about this, which are the research that could be done? Curricular discussions and program, learning and teaching, teaching materials, student understanding, teacher understanding, concept development, teacher education, non-school programs, history and philosophy of science, history of astronomy education, and review of academic research. So it's very common to see in the literature some conceptions of children's understanding about day and night, phases of the moon, seasons. These drawings are very, very known in this area, okay? But some results obtained for surveys available in the literature of the area show features, trends, shortcomings, recommendations for the future research. In the international literature, some of the state-of-the-art works in the field of astronomy education can be found. I would like to give some examples of these papers as a review of research related to astronomy education from these authors. This is wow. So Bishop, United States Astronomy Education, Past, Present, and Future. Bailey, Prater, and Slater, reflecting on the history of astronomy education research to plan for the future. And Bailey and Slater, a review of astronomy education research. And Slater, the first big wave on astronomy education research, dissertations, and some directions for future research efforts. So, I think that 2010 we have Leliotta and Honig about big ideas, a review of astronomy education research from 1974 to 2008. It was a survey of 103 peer-reviewed articles of journals, and the big ideas, very known, as I told you, is for Earth, gravity, day and night cycle, the season, Earth and Sun and Moon system. So there are many studies as stars, the solar system, and the concept of size and distance. It is recommended for future research to across the disciplinary boundaries of astronomy education at school and teacher education levels, and aim to disseminate findings more effectively with the education systems. So the efforts of the potential perspective, I will give you the example of Brazil, of this kind of analysis. We have the PhD and master thesis that me and my colleague Megid Neto, we made a first review in 2005. There was only 16 works. So now we have efforts based on to put an archive. An archive it's available online, okay? So we have at about 121 works that you can see the production over there, okay, this output. Proceedings of meeting, we have a study about the production of the annual meetings of the Brazilian Astronomical Society. Last week we were there in another issue, okay? So the national meetings of research in science education, we have a survey, me and one of my students, at about 75 works. Not so much, but we are trying to organize and to make it available to the community. This is very important, okay? So we had the National Symposium on Astronomy Education, and the proceedings are available too online. We have the first and the second, and the next will be planned to be this year on October. And we have at about 170 submitted works, okay? So the published papers on Brazilian Journal of Education. We have the RELAA, the Relating American Journal of Astronomy Education, that I am one of the editors. You can submit, please, articles to the journal. And this is the outputs of this publication, the articles per year. We have something about the articles per issue. It's not very much. It's about 4 or 5 in the average, okay? But we still maintain, and this year will be the 10th year of existence of the publication. So, about international initiatives. As Pedro has told you, we have the International Astronomical Union and the Commission 46 related on astronomy education. On the, some recent working groups, we have, I'm the chair of this one, Theory and Methods in Astronomy Education. It's devoted to astronomy education research, okay? So, the proposal of a project for the encouragement of studies and programs and research projects for astronomy education is something that's about. It is increasing the numbers of researchers, doctors, researchers meeting and publications in the area. It's a very common through the world. The Commission 46 could have an important role to recognize, encourage, and promote such efforts. Actions and activities in international level for development, teaching, outreach, and communication programs are important and necessary. But Commission 46 in IAU could promote further studies in educational research, as has been done by other years of knowledge in science in particular. If you see in the community of physics or biology or chemistry, it's very common for many years of tradition. But on astronomy, to make research and education, I think it's pretty new, okay, on the community. So we have some proceedings of IAU meetings on astronomy education. I don't know if you heard about, it was many meetings, and we have a survey about these meetings, and we have published a paper on astronomy education review. Unfortunately, this publication is shut down, okay, it's closed now, finished the publication, but on 2011, we published an analysis of these papers, and the most important of these results, it's that at about almost 70% of the communications of these meetings was dealing on reports of education experience, mainly making reports of actions and not deeply on education, okay, as an education problem. So in the General Assembly of AU of Rio and Beijing, we have many abstracts that could be analyzed. In IAU meeting have been characterized more by reports about practical education, matters and exchanged experience, and not by scientific research in the field of education itself. The efforts to elevate astronomy for public outreach and classroom are always suitable for the exchange of experience as a great academic and educational forum. There's no doubt about. But, however, from the point of view of educational research, deeper treatments that deal with the epistemological question, teaching and learning process proper of the era of astronomy at different school levels and theoretical framework are necessary as a development of the area of the knowledge of this particular area. A deeper look could stimulate the development of scientific investigation in astronomy education analogously to the other areas of knowledge. So the demand has been mentioned in the strategical plan, as said by Pedro, and there are publishing papers in astronomy education, some known journals of science education, but there are journals on astronomy education, as our RELAY, the Latin American journal, or Education Astronomy Review, unfortunately, has closed at about almost 20 issues until 2013. We have this journal and review of astronomy education and outreach that was published in only one number. It's pretty new, but it's available only by press edition, not online published. But this is an announcement that I would like to make to you, I would like to talk. It's a new journal for astronomy education. It's accepting manuscripts, pretty new, and the editor-in-chief is Tim Slater from the University of Wyoming. They are asking for submitting papers that would be this first number in December. So other publications in astronomy education, as you know, the Universe in the Classroom Astronomer, the GNOMO of the Association of Astronomy Education, but this is closed, I think, because the last number is from some years ago, and the IAU Commission 46 newsletter. So lots of suggestions and experiences, material by hard science practitioners is not enough, as I told you. We should see whether they work and how an educational theory and framework guides us to actually improve teaching. The possible strategies based on the Commission 46 to promote these efforts is to ask for cooperation of the national liaisons on the International Astronomical Union, publish notes about the meetings, as this one, publish surveys or publish papers about astronomy education research in journals, and support for meetings about this, and others. If you have any idea, I would like to listen to you, okay? Some ideas of the Commission 46, something like symposium on how astronomy education research results can impact teaching in true, okay? How-to workshops for people wanting to start doing research, to making a roadmap meeting to prioritize efforts for the next 10 years, okay? Joint observation plan for the international survey and comparison with the citizen astronomy knowledge. And more than this is the most important for me. Why are we teaching astronomy? Why is teaching astronomy for? What's our objective to teach astronomy? To make the people knowing something else about the universe. How could be different people because of this knowledge? And support the publishing of proceedings of state-of-the-art, as I told you, of current astronomy education research findings. This could be in many areas of the world, in many languages. So, because of this, suggestion is graduate studies, meeting, encourage the publications in journals, but research could be made not exactly in these standards, something like introduction, problem, methodology, results, discussions, and conclusions. But discussing any idea, anybody, any teacher could do this, not exactly with this scheme, but if you have a discussion, you have to be a problem, you have to be a methodology to see the data, you have to discuss and to have the results, data gathering, and make a discussion, and finally the conclusions. Any talk could be like this. So we think that any teacher, as some authors told about, is it possible to be teacher as a researcher, not exactly as a researcher, as an academical career, but as a teacher, is it possible to be a researcher? As said by Lawrence Stenhouse or John Elliott. John Elliott is still alive and doing many works on Asia about giving classes and making movies of the classes and discussing the classes, okay? Reflective teachers, started by Donald Chan, make the things about, let me say, something to relation on the practice of the teacher. And as Paulo Freire, our education author in Brazil, there is no teaching without research and no research without teaching. So important considerations. It's very important to say that in different contexts of production, when you are teaching and when you are researching, it's very important to take in account that different contexts of production not easily transferred between countries or regions of the same country. So this content has to be respected, okay? And the applications in the school with local teachers and the general public. The application is very important. So to take in account the context, because there is some cultural problems. The curriculum is very specific for each region and each country. And the applications is very, very much necessary, okay? So this is that I would like to talk to you and would like to listen for your questions. Thank you very much. I would like to thank for the organizers to invite me to be here. And it's okay, it's finished. Thank you.
It's a breathtaking talk. The sheer volume of slides was inspiring. Is it possible that the Latin American journal might morph into International Journal of Astronomy Education?
Yes, if I understand, is it possible to see this American journal as an international journal of astronomy education? Yes,
Yeah.
this is the objective of this journal.
So you would accept manuscripts from United States for
Yes,
publication?
and for our journal in Brazil, named Latin American Journal of Astronomy Education, we received many articles from the United States. We have published in the two last numbers at about three papers from Americans.
Oh, great. That's
Yes.
fantastic. Thank you.
Yes, we are glad. As an international journal, in fact.
Thanks for a great talk, Paulo. I was
you.
wondering if you could just say a short summary about what are like current or new astronomy education research directions. You kind of told us where to look to find out, but can you just give us a summary?
Yes, I don't know exactly how to give this answer, okay? But I think that different frameworks, it's very common to see in the publications trends about conceptions, okay? Some authors have said that many conceptions are very now at this moment, okay? You have to drive to other objectives. One of them is to give different frameworks and to give different objectives on topics, for instance, about stars, about galaxies, about new technologies, okay? You know that gravity, seasons, phases of the moon, and something like this is pretty new, okay? We have to move on. We have to go out in the space, really, okay, to publish and to investigate another conceptions. And not only conceptions. From my point of view, I think that there is an epistemological problem of astronomy, problem in the good sense, okay? And what's the difference from astronomy to the other areas? We know, but we have to investigate and we have to publish to say about this, okay? I don't know if I answered you.
No more questions? Paulo, thank you very much for the brilliant talk.
Thank you very much.
We move now to Rebecca Barnes from Education at ESA. It's talking about education at ESA, inspiring the future. It's really a privilege to have Rebecca Barnes, with whom we've been working for some years now, having a lot of fun and making some of the most popular teacher training in the Galileo Teacher Training Program series. So, Rebecca, I'll let you know 5 minutes in advance. Thank you for coming.
Thank you very much, Rosa. It's a great privilege to be here. Thank you very much for inviting me to speak. So, as I said, I'm Rebecca Barnes. I'm going to tell you a bit about the ESA Education Programme. For those of you who aren't perhaps so familiar with ESA, the European Space Agency, I thought I'd just tell you very briefly who ESA is. So ESA is made up of 20 member states. 18 of these are countries that are part of the EU. And in addition, there are Norway and Switzerland. And there are another number of countries that work with ESA under cooperation agreements. And Canada also works with ESA. So all of these countries work towards common goals in space, and this is what they do. ESA covers nearly all areas of space activity, space science, human spaceflight, exploration, Earth observation, launches, navigation, telecommunications technology, and operations as well. So that's just a very brief overview of ESA. And one of the most important tasks of ESA is to inform the public about the latest advances and discoveries in space. And this includes inspiring young people. And therefore, the objectives of the ESA education program are to motivate and enable young people to enhance their literacy and competence in sciences and technology, inspire and enable young people to consider pursuing a career in the STEM field, in particular the space domain, and to contribute to increase young people's awareness of the importance of space research, exploration, and applications of this in modern society and the economy. So for ESA education, young people means those aged between the 4 and 28, right through the education system. This is a large target audience to cater for and presents some challenges. The number of people, there are a large number of school children and school teachers that we need to reach. There are 20 different countries that are the member states and 15 different languages. In many countries, there are different education systems and curricula that also needs to be taken into account. So there's just some of the challenges that are faced. Now, to approach these challenges, the ESA education program is diverse. It's a diverse range of activities that are designed for specific age groups. So I'm going to tell you some more about some of these activities. And starting with the EZERO project. This is the EZERO stands for the European Space Education Resource Office. And this project supports the primary and secondary education community in Europe. The EZEROs are distributed across ESA member states and are staffed by local experts who have strong synergy and partnership with their national education authorities and networks. And they're co-funded by ESA and the national funding bodies. The activities, the sort of activities that are run by the EZERO network include adapting resources to local curricula and languages. They run teacher training, both formal and informal. And they create awareness of space amongst teachers and their students. They also provide a link between ESA and the national education communities. So each EZERO is unique, but they offer a common brand. And here's a map of the current EZEROs. So they're not across every member state just yet, but there are a large number of them. And there's one here in Portugal, and I think you're going to hear a little bit more about the Portugal EZERO and also the Belgium EZERO, I think, later on. Now, so the teacher training is organised in some of the EZERO offices for their countries. And ESA also organises teacher training where we get teachers to come to us. So we have an annual summer workshop for teachers. This is based at ESTEC, which is the ESA site that's in the Netherlands. It takes place in the summer holidays, or for some teachers, the summer holidays are at the beginning of the summer. We select 40 STEM teachers based on an application that they make to us for a place on the workshop. And these teachers, we try and get as many countries of the ESA member states, incorporating states represented as possible. The objective is to show how space can be used to teach STEM in the classroom. The programs are diverse as diverse as possible. We mix practical sessions with inspirational talks and presentations by experts. We use them to showcase and test and pilot new ESA resources as well. And we give opportunity for the teachers from all these different countries to network with each other. So the fifth one in this series of workshops took place in July, and we hope to be able to run another one next summer. If it's possible to run one next summer, the announcement will be made in spring next year. So the other training that we run, I should just add that the annual summer workshop looks at all of the different areas of space that space activities that ESA is involved in. And we also collaborate with the Galileo Teacher Training Program. And these are the workshops that Rosa was just describing to you. And for this, the next workshop will actually take place in December this year in Leiden, again in the Netherlands. And so it's on the 8th to 12th. The announcement that it is open for application was made just last Friday. So I encourage you to apply. Also to tell your colleagues who you think might be interested in attending. You have until the 13th of October to get your applications in. And we'll select just 20 teachers based on the information they give us in the application form to come and attend. And again, we'll try and get a widespread of as many countries as possible. These workshops also show how to use space as a context in the classroom, but this one focuses on astronomy and space science. Again, the program includes practical sessions, inspirational talks, and presentations by experts, and also provides networking opportunities. So for this workshop and for the summer workshop, as you can see, we can only support a very small number of teachers to come to us and receive this training. Therefore, when teachers apply, we ask them to consider what they will do with the information that we give them. How will they enable us to multiply the effect of the workshop? So we ask them to think about they will go back to their hometown, their home country, and tell their colleagues about it in their local region, town, nationally, by organizing workshops, volunteering to run sessions at conferences, write web articles, news articles, whatever they can manage. This is something that is really, really important to us to try and spread this out to as many teachers as possible. Okay, so as well as teacher training, the education program includes hands-on projects and competitions. And these are generally very practical, but as well as the practical skills that are involved in completing the projects and tasks for the competition, they also encourage teamwork and other skills such as data analysis, presentation skills, scientific inquiry. They tend to be quite long duration, but no more than 6 months in length. I'm going to describe a few of these to you. The first one is one that's aimed at primary students aged between 8 and 12 years. And this one's called Mission X, Train Like an Astronaut. And Train Like an Astronaut is an international education challenge that focuses on fitness and nutrition. And ESA teams up with NASA and other space agencies to run this competition. The call for the competition in this academic year should be out very soon, within the next few months. So keep an eye on the ESA Education webpage. I've got some links at the end of the presentation to find out where to look, where to keep checking, and when you can apply if you're interested. Okay. One secondary project is called CANSATS, and I think some of you probably have already been involved in this competition before. Yeah. And so the CANSATs, they are a simulation of a real satellite that's contained within the volume and shape of a soft drinks can. So it's quite a challenging project for students to do. Within this little tiny can, they have to include all of the major satellite subsystems, power, communications, and as well as this, it has to perform a mission and be able to land safely. Now, many countries have their own national competition, and in 2014 there was a European-wide competition as well. I understand that the call for this competition will be launched at some point. This academic year's competition will be launched at some point over the next couple of months. So again, keep an eye out on the ESA Education webpage. I've just got some pictures to show you how we get an idea of the size of the little satellites, and they get launched, the team's working on it. Now, the Zero Robotics project is a competition that challenges students to write code to instruct and control a small robot that's about the size of a volleyball. And they have to control this robot through an obstacle course that's on the International Space Station. And it's, again, it's an international competition. There are the schools in the US also take part. And there was a European competition last year. As you can see that about 500 students from 9 different countries participated. The competition call for this next academic year came out in July. And the deadline's pretty close. It's on the 26th of September. So if you are interested, you can find out more information on the education webpage. And when you make the application, I think you have to also do a little bit of planning and preparation to be able to register for this competition. Now, so those are some projects that are ongoing, and there have also some pilot projects that have taken place over the last couple of years. And these are both in using test facilities that are actually at ESTEC in the Netherlands, ESA Centre in the Netherlands. There's a drop tower there, and you can see it in the picture. And so the students have designed experiments to study what happens as things get dropped in this tower. The other one is using the centrifuge. But again, these have been pilots, and they're now the results of these pilot projects are now being looked at to see how this could be extended, where it could go for the future. So for the ESA Education program has some classroom resources as well. The current resources you can find, they're freely available to download on the ESA Education website. They're not that easy to find, I have to be honest, so this screenshot shows you where to find them. If you go to www.esa.int/education, you'll see a tab that says Teacher's Corner, and they're listed in the left-hand menu. You'll see a number of different topics, areas of space activity, and you'll find the relating resource under there. So those are the existing ones that are available now. And there are a new series of resources under development that will be called Teach with Space. And these classroom resources will consist of a teacher guide, student worksheets. Some will have experiment videos to accompany the teacher guide, multimedia, picture packs, and much more. And I'm going to talk about exactly a little bit more about these in just a moment. As well as the development of new resources, the existing ones have recently been audited by an education research specialist group, and based on their recommendations, these will be updated and refreshed over time. So the new classroom resources will have it. I don't know if you can see it very well on the projector, this light blue color. And they will be they'll all have the same look and feel. This just gives you an example of what the front page might look like, and then the first page inside will tell you hopefully everything you need to know about what's in this resource, so you can decide whether it's something you're interested in using, you can use, before you plow through the rest of the pages. So it has information about what it's aimed at, how much it would cost, how long it would take to prepare, how long it would take to run in the classroom, and a quick summary overview. So there will be some primary resources that will be published or that are in preparation. And these are actually based on a set of lessons that were developed by the Zero office in the Netherlands called Journey to Space in 80 Lessons. And we've selected a few of these that we will relate to the Rosetta mission. And hopefully you all know about the Rosetta mission. It's quite an important couple of years for this. And so we are going to add to these resources a context for this mission and comets, and they will be available soon. So they'll be aimed at primary students. Also for continuing with the theme of the Rosetta mission, ESA has collaborated with the European Network of Science Centres and Museums, EXCITE, and there is a Rosetta kit that's available to the the Excite members. And one of these is an education workshop that was developed by the Nemo Science Centre, which is in Amsterdam for ESA. And so it's for students, groups of students aged 8 to 12 that come into a science centre. The science centre can take this package and run it with their students. It's about an hour's long. It's a mixture of presentations, hands-on experiments, and demonstrations, all about the Rosetta mission. Hopefully, we hope that at some point we can make this available for teachers to use in the classroom and adapt the workshop so that to that environment. Another new primary resource, not to do with Rosetta, this one's about space materials. This has been developed by Nottingham Trent University for ESA, and they have to select the right materials to build a spacecraft. This is under development, and it should be available at some point next year, and they're also looking to upgrade it to be able to use it at secondary level as well. Okay. And the last primary resource that's under development is called Taste in Space. It will be related to Mission X in 2015, and it'll be again about more biology themed, and it will also relate to the Futura mission of Samantha Cristoforetti. I'll probably pronounce that very incorrect, but she's an ESA astronaut. And this will be delivered in the next few months as well. So there'll be part of this package will be some lesson plans to use at primary level. Okay, the new secondary resources will include 30 new teacher packs. Now, these won't be released all in one go. We're going to release them gradually over the next year. So as I said, these have teacher guides, videos, demonstrations. These have been developed by the National Space Academy in the UK for ESA, and aimed at the higher end of middle to upper secondary level students. The first ones to be released over the coming months will be in the context of the Rosetta mission. So the aim of the new resources is not to say, here's an ESA mission, here's all about it, here's some physics that you can do in the classroom. The idea is to take curricular science and then show show its link to the mission and other ESA science. So it's going to be focused on the content rather than the context. The context will come at the end. Now, there have been some new videos that were released in July. You can find them, they're available on the ESA webpage. And they are based around the ATV, the Automated Transfer Vehicle, which delivers cargo to the International Space Station. The last ATV launched in the summer, in July. And so these videos use the context of the ATV and use the names. They're all named after, each ATV there's been 5 of them, are named after scientists and visionaries. And so each video looks at the scientist and the visionary and and the context of space and ATV that they relates it to. So they're available now. Okay, so we have new material that's going to come out over the next year that will be based around the down-to-earth impact calculator. Now, this is an online resource that you can find to use now, and this is developed by the Fulks Telescope project with ESA, for ESA. These specific lessons have been developed by the Fulks Telescope project with ESA to use with the down-to-earth impact calculator. Some of these will be relating to the Rosetta mission as well. And again, as I said, they'll be available over the next year. So moving on a bit from the things that are related to Rosetta, we have some new resources that are going to be also in the context of the Gaia mission. Now, Gaia was launched at the end of last year, and it's making a map of stars within the galaxy, within our galaxy, the Milky Way. And this satellite, from this information that the satellite is taking, it's going to build a 3D map of our galaxy. So these lessons were based around the topics of this mission. And finally, ESA have recently teamed up with LEGO. So there'll be some prototypes demonstrating orbital robotics and the use of the ExoMars rover. There will be 10 lessons will be developed around these prototypes, and these will be available. Again, this one's really just started, so these will be available at some point next year. Okay, so there's a very short summary of the education material that is under development and will be made freely available on the ESA Education website to everyone over the next year. I just want to then move on to some other things in the ESA Education program. And one is the more formal side, informal side of things, I should say. There is a website that's directed at primary-aged children called ESA Kids. And there you'll find news articles and little animations and descriptions of various topics aimed at this age group, aimed at the primary reader, a competition and little interactive things to do. And the mascot of this website is Paxi. His role is to explain, his little alien mascot, his role is to explain space to children. And he also likes to attend major ESA events and other space events. So if you follow his Facebook and Twitter, you can find out where Paxi's been. And Paxi will be the narrator of some new animations that will be that are currently in production and will be put on the ESA Kids website. And they will guide you through the solar system. Also tell you more. He will also tell you more about the Rosetta mission. He also stars in his own book, and that's available to download from the Paxi website. It's an activity book, so there's colouring in, games, and games to play. It's aimed at the very young audience. You'll find that on the ESA Kids website. So we've looked at mostly the primary and secondary level. There are projects. I said that the education program goes up to 28, so there are a number of projects that ESA runs for university students. These tend to be quite long duration and very involved, and they really encourage students to work together in teams to develop real hardware and fly real hardware and do real projects. This is just a short summary. The more information about the university projects can be found on the ESA Education website. So I said that there are some links, and so here are a number of links. There's the main web page, there's a Facebook account. You can find out an overview of the education program in the brochure. The ESA Kids website, there's Facebook and Twitter pages, and more about the Year Zero available there as well. So thank you very much for listening. Hopefully I've not given you too much information. Thank you very much.
It was certainly a lot. Education is never too much. I have the microphone, so I'll give myself the privilege. You said that all the materials are available for free, but some materials are accompanied by kits.
Sorry.
Some of the materials are accompanied by kits, physical kits.
I think for the projects, like the CANSATs and these hands-on projects, you need it.
Or the Rosetta one that you said had a kit for the Excite.
Yeah, so that's actually the exception at the moment. The kit includes an education workshop, but it also has exhibition material, and that's available at the moment only to Excite members.
So schools, if they want to purchase it, is not available for them?
I don't know. You could try, but we don't really want schools to go and buy it. We don't want them to pay for this workshop, so we're going to try and make this available for everyone to adapt it to the classroom. So
And-
if you can contact me and we can.
In Lego, is it going to be with a moderate price, the rovers developed?
I'm going to be honest and have to say I don't know much about this the Lego project at all. It's only just started, but I thought I'm not sure.
Just to say that the Knowledge Pavilion will have the Rosetta exposition. We are mounting it right now, so in November, probably for the Philae docking, it will already be there. So schools can visit there instead of mounting it itself.
That's a very good point, thank you.
Will it go across the country as well, or only at the Knowledge Pavilion?
Right now only there.
Okay.
Maybe others.
Science centers.
Yeah, if a school's interested in visiting a local science centre, they can get in touch with Excite to find out where, which science centres and museums are going to be making these Rosetta exhibitions, so they can visit them.
More questions? Okay, I have one more. What about countries outside Europe?
Countries outside Europe. The education program focuses on the Eastern member states and the cooperating states. But as I said, the education material that's on the websites are free to download.
But the kit?
The kit for the Rosetta mission, again, I think if they'd have to ask, get in touch with Excite to find out about that, because they're the European network, but.
Okay, great. So we reach coffee break time. Yay, coffee! So everyone. And people that are presenting in the next session, please come and give us your presentation. And we reconvene at 11.
Thank our speaker.
Shall we thank our speakers again?
I'm overwhelmed.
Oh,
Rosa, wait.
I come back. I'll just put this back. Hã? As 11? Ah, faltam-nos almoço.